Alternatives to general relativity. Alternatives to general relativity are physical theories that attempt to describe the phenomenon of gravitation in competition to Einstein's theory of general relativity. There have been many different attempts at constructing an ideal theory of gravity. These attempts can be split into four broad categories based on their scope. None of these alternatives to general relativity have gained wide acceptance. General relativity has withstood many tests, remaining consistent with all observations so far. In contrast, many of the early alternatives have been definitively disproven. However, some of the alternative theories of gravity are supported by a minority of physicists, and the topic remains the subject of intense study in theoretical physics. History of gravitational theory through general relativity. At the time it was published in the 17th century, Isaac Newton's theory of gravity was the most accurate theory of gravity. Since then, a number of alternatives were proposed. The theories which predate the formulation of general relativity in 1915 are discussed in History of Gravitational Theory. General relativity. Motivations. After general relativity, attempts were made either to improve on theories developed before general relativity, or to improve general relativity itself. Experimental tests improved along with the theories. Many of the different strategies that were developed soon after general relativity were abandoned, and there was a push to develop more general forms of the theories that survived. By the 1980s, the increasing accuracy of experimental tests had all confirmed general relativity. No competitors were left except for those that included general relativity as a special case. Further, shortly after that, theorists switched to string theory, which was starting to look promising, but has since lost popularity. In the mid-1980s, a few experiments were suggesting that gravity was being modified by the addition of a fifth force, or, in one case, of a fifth. Motivations for the more recent alternative theories are almost all cosmological, associated with or replacing such constructs as inflation, dark matter, and dark energy. Investigation of the Pioneer anomaly has caused renewed public interest in alternatives to general relativity. Notation in this article. Classification of theories. Theories from 1917 to the 1980s. Scalar field theories. Bimetric theories. Quasilinear theories. Tensor theories. Einstein's general relativity is the simplest plausible theory of gravity that can be based on just one symmetric tensor field, the metric tensor. Others include Stravinsky R+R2 gravity, Gauss-Bonnet gravity, FR gravity, and Lovelock theory of gravity. Stravinsky, Gauss-Bonnet, Stele's fourth derivative gravity, FR infinite derivative gravity, Lovelock, scalar tensor theories, vector-tensor theories, other metric theories. Others metric theories have been proposed. That of Bekenstein is discussed under modern theories. Non-metric theories. Modern theories 1980s to present. This section includes alternatives to general relativity published after the observations of galaxy rotation that led to the hypothesis of dark matter. There is no known reliable list of comparison of these theories. Those considered here include Bekenstein, Moffat. These theories are presented with a cosmological constant or added scalar or vector potential. Motivations. Motivations for the more recent alternatives to general relativity are almost all cosmological, associated with or replacing such constructs as inflation, dark matter, and dark energy. The basic idea is that gravity agrees with general relativity at the present epoch, but may have been quite different in the early universe. In the 1980s, there was a slowly dawning realization in the physics world that there were several problems inherent in the then current Big Bang scenario, including the horizon problem and the observation that at early times when quarks were first forming there was not enough space on the universe to contain even one quark. Inflation theory was developed to overcome these difficulties. Another alternative was constructing an alternative to general relativity, in which the speed of light was higher in the early universe. In the 1990s, supernova surveys discovered the accelerated expansion of the universe, now usually attributed to dark energy. This led to the rapid reinstatement of Einstein's cosmological constant, and quintessence arrived as an alternative to the cosmological constant. At least one new alternative to general relativity attempted to explain the supernova survey's results in a completely different way: the measurement of the speed of gravity with the gravitational wave, cosmological constant, and quintessence. Farnes' theories, relativistic MEND, Moffat's theories, scalar tensor vector gravity, infinite derivative gravity, testing of alternatives to general relativity. Any putative alternative to general relativity would need to meet a variety of tests for it to become accepted. Self-consistency. Self-consistency among non-metric theories includes eliminating theories allowing tachyons, ghost poles, and higher-order poles, and those that have problems with behavior at infinity. Among metric theories, self-consistency is best illustrated by describing several theories that fail this test. The classic example is the spin-2 field theory of Farnes and Pauli. The field equations imply that gravitating bodies move in straight lines, whereas the equations of motion insist that completeness. Classical tests. There are three classical tests dating back to the 1910s or earlier of the ability of gravity theories to handle relativistic effects. They are gravitational redshift, gravitational lensing generally tested around the Sun, and anomalous perihelion advance of the planets. Each theory should reproduce the observed results in these areas, which have to date always aligned with the predictions of general relativity. In 1964, Erwin I. Shapiro found a fourth test, called the agreement with Newtonian mechanics and special relativity, as an example of disagreement with Newtonian experiments. Birkhoff theory predicts relativistic effects fairly reliably but demands that sound waves travel at the speed of light. This was the consequence of an assumption made to simplify handling the collision of masses. The Einstein equivalence principle. Einstein's equivalence principle has three components. The first is the uniqueness of free fall, also known as the weak equivalence principle. Schiff's conjecture states that any complete parametric post-Newtonian formalism, strong gravity and gravitational waves. Parametric post-Newtonian is only a measure of weak field effects. Strong gravity effects can be seen in compact objects such as white dwarfs, neutron stars, and black holes. Experimental tests such as the stability of white dwarfs, spin-down rate of pulsars, orbits of binary pulsars, and the existence of a black hole horizon can be used as tests of alternative to general relativity. Cosmological tests. Many of these have been developed recently. Results of testing theories. Parametric post-Newtonian parameters for a range of theories. Theories that fail other tests. Footnotes, notes. References,